In today's video, we are going to talk about an interesting tool. And this particular tool is specifically used for advanced physics simulation named MuJoCo. Now, when we come on to this particular website, mujoco.org.org, then we find the related information, including the download documentation and the GitHub related page of MuJoCo. I was randomly searching for some of the simulation tools, and then I came onto this particular page and got to know that yes, it's a quite useful and wonderful physics simulation platform. So if you are a physics enthusiast, and it's not like this that you are only physics enthusiast, then only you are supposed to use such platforms. No, it is not like that. Suppose you are a specific tech enthusiast, including the robotics and all, then you do need the physics simulation and the sort of activities. So then also it is going to be quite wonderful for you. So let's start with the basic definition. Hey there, my name is Rohit Kumar, and today we are going to consider the MuJoCo, the basic coverage and some of the related doubts. So here we have with the basic definition of MuJoCo. What it is a free and open source physics engine. Now, when we say that it's a physics engine, so it is going to simulate the kind of physical properties and the physics related activities with respect to a particular object. So here it is important free and open source because mostly we have either a free product or the open source product. But if it is free and open source both, then it's going to be really wonderful because open source means the code is available. But if it is not free, then you are not supposed to use it as you wish. But if it is free, you are supposed to as you wish. And if it is not open source, then again it's an issue because you cannot modify the basic functioning or the core working mechanism of that particular product. So it is allowing you both the things, and that's why it's a wonderful. Additionally, it is supposed to facilitate the research and development in robotics, biomechanics, graphics, and animation. So now you can relate yourself that if you are working in any of these fields or the related fields, then this particular tool is gonna help you. Now coming to the specific thing that where it is going to actually offer some of the related powers, means some of the related things that is going to help you out. So it is going to offer you a unique combination of speed, accuracy, and the modeling power. And usually we see that any simulator which we use is supposed to offer you these sort of things, means it should model the things with a sufficient level of accuracy as well as the speed. And both the things are included over here. Coming to the further details, so it is saying that it is the first full-featured simulator designed from the ground up for the purpose of the model-based simulation optimization, and in particular optimization through context. So when we usually go for the optimization, then there are different sorts of optimization possible. Doesn't matter in which field, whether you are talking about the biomechanics, whether you are talking about the graphics, means the graphics related research or the sort of processing. Additionally, whether you are working in the field of robotics, there are number of optimizations possible, and those optimizations depend on the kind of activity which you are performing with the background. So that's why it is always possible that optimize in a particular way or optimizing the particular scale. That particular scale you need to measure, then you need to decide whether you want to go in the right particular direction or not. So in particularly, it is saying that it is offering you the optimization through context. So that's quite a wonderful feature to have. Then we have the MuJoCo makes it possible to scale up computationally intensive techniques such as optimal control, physically consistent state estimation, system identification, and the automatic mechanical design. Now, here, these sort of things that you are finding over here, these are supposed to help you out while you are scaling up. So the scale up issues come onto because in most of the system, scalability is a major challenge. So if you are having the scalability in your system, then obviously the first thing comes whether you are having the right sort of control as of now, whether means you are having the optimized control as of now, right, as you were having the control previously in the system. So if the number of devices are going to increase or the contact points are going to increase, then that level of control as you are having with less number of points or less number of contacts is gonna bit difficult. So it is offering you the same sort of things that when you are having the large number of or the computationally intensive things, then the optimal control and the physically consistent state estimation as well as maintenance, these things become quite difficult. So these things are guaranteed or at least promised by MuJoCo. So that's again quite good thing. Now there are multiple other related things, including the scientific visualization, virtual environments, animation, gaming related deployment, as well as the interaction and the control schemes that have been discussed over here in this particular page. Now, if you come on to the key features of MuJoCo, then it is saying that it is going to offer the simulation in generalized coordinate, avoiding the joint violation, and the inverse dynamics, which are well defined even in the presence of context. It is also offered by MuJoCo. Then you have the unified continuous time formation of constraints via the convex optimization. So convex optimization, which is a form of optimization. At this particular optimization, you can achieve also with the kind of other different optimization tools, including the IBM Simplex, even if you are using the AMPL and you are having the Gurobi and sort of things, where you are supposed to form your own physical coordinates or the sort of context optimization problem, and then you can go for the convex optimization. So doesn't matter which tool you are using. The only thing is whether the related features are supported or not. So same thing it is saying that with respect to convex optimization, it is offering you the unified continuous time formulation of constraints. So with respect to any optimization problem, constraints become an important feature. And if you are going to have a system where you need the continuous time formation of constraints, then it becomes a bit difficult, because if you are the sort of designer of that particular optimization problem, then having a unified continuous time formation of constraints becomes an issue, because many times we don't have the right sorts of understanding of the background system while designing the particular optimization problem. Additionally, if you are having the real and the actual definition of that particular constraints, still the merging of that particular constraints with respect to the current optimization problem without affecting its actual optimization goals. That's the actual thing that matters. So that you need to take care of. Then we have the constraints, including the soft context limit, dry friction, and the equality constraints. Simulation of particles systems like the cloth rope and the soft objects, and the actuators, including the motors, cylinders, muscles, tenders, etc. Then the choice of Newton conjugate gradient, the projected Gauss Seidel solvers, etc. The choice of parametrical and elliptical friction cones, dense and sparse Jacobians, etc. Means multiple optimization related things, and the mathematical features are provided over here. Additionally, coming on to the specific feature, you have the intuitive XML model format called the MGCF and built-in model compiler. Most of the means simulators offer you the compiler sort of activities. There might be a built-in compiler, or it might be a sort of extended compiler, which is coming as the extension of that particular tool. So that's the difference. Then you have the cross-platform GUI with the interactive 3D visualization in OpenGL. OpenGL support is quite important, especially for computer vision and the visualization related things. Then you have the runtime module written in ANSI C and the hand-tuned for performance. And now, those who are not familiar with the ANSI C, so ANSI C is a standard form of C, because C originally was not so much standardized. So multiple organizations came up with the different versions of C. So specifically, then the American National Standards Institute came with a specific formation and the standardized form of C, that was ANSI C. So these are some of the specific and the key features of MuJoCo, and hopefully you must have liked the details. If you are interested to explore more, I will suggest you to go through the download page, and you can just simply download the things over there. You just simply right click and open it, and you have the important and the related documentation, and the GitHub page is also given over here. So I think no issue is going to be there, and it is going to take you to the DeepMind page. And that DeepMind page, you are going to have the MuJoCo implementation. Then you have the basic coverage with respect to the documentation. It is taking a bit time. I think my net connection is a bit slow. So no issue. We landed onto the DeepMind page with respect to GitHub repositories. And here you can see that they have given the code. So if you are interested, just go. And it's the MuJoCo. It's the acronym for multi-jointed context, if we specifically take that term. So because though it's the standing for the full form multi-jointed dynamics with the context. Okay. So these are the things, installation details, including the pre-built binaries and building from the sources. These are the sort of things available. Python, they are recommending that either 3.7 or higher version is required. Then how to get started, etc. And the some of the basic related questions, the kind of software related things, how to do the kind of conversion with respect to the OBJ and the SD format and the OpenSim. These things are also given over here. So I think quite detailed documentation they have given with respect to coding implementation. Additionally, whenever you are going for any particular work implementation from a particular author's page or from a particular Git page, it's a common ethics that you always cite the work. So that's the citation related thing. And you should, and I will say, I will recommend that you should always do the citation practice, because it's the ethical thing and it will make your work a kind of ethical one. Okay. So let's close it and learning on to the MuJoCo. So they have given the detailed information over here. What we talked about there at the general page, at the home page. So all these things are the kind of features we were discussing over here. These are given over here in detail. So they have talked about the computation, modeling, XML reference, programming models, API reference, Python bindings, etc. Multiple things are available over here. So just to go through them and see whatever you want to find out. Then we have the GitHub page, and it is the DeepMind page. So again, this page is not going to offer you the code related details. It is just going to offer you the kind of different releases. So these are the sort of different releases with respect to different platforms. So we have the Linux implementation, we have the Mac implementation, the Windows implementations, etc. Then some of the general information and the Python bindings and some of the bug fixing related information is given over here. So I hope you is gonna enjoy this particular platform. And if you want to have a little glimpse, so here you can see that how it is gonna look like. And it's seemingly quite wonderful, means quite interactive and quite interesting visualization they have given over here. So hopefully it is going to help you out in your research work. So that's all from my side. If you didn't like anything, please do comment below and let me know how we can improve the videos further. I will definitely consider your comments. These are gonna help us out with some of the related criticism and gonna give us some of the related insights that will improve the videos further. Thanks for watching. Happy learning.